Hello everyone, welcome to another JavaScript problem solving. So today's problem is number of square in an n multiplied by n grid. Create a function that calculates the number of different squares in an n by n square grid. Example, if the square is 2, then the output is going to be 5. If the n is 4, the output is 30. If the n is 5, then the output is 50. Now, here is some explanation. If n is equal to 0, then the number of square is 0. If n is equal to 1, then the number of square is 1. And 2, then it is 5. And 3, then it is 14. As you can see, for each value of n, the number of square is n squared plus the number of square from the previous value of n. So this is very important to remember. And there are some note: input is positive integer and square pyramidal number. So let me visualize this for you, what this means. Now, if the number n is equal to 1, then there is only one square, right? 1 multiplied by 1, 1. So we can see here is a 1 square. Now, if we go here, n is equal to 2, then there are 5 squares. How? 2 multiplied by 2. There are 4. So 1, 2, 3, 4. And where is the other one? The other one is, let me draw this for you. And the another one is this one, right? The whole one. So 1, 2, 3, 4, and 5. So when n is equal to 2, we have 5 squares. Now let's go to the, if n is equal to 3, how many squares do we have? Here we can see that we have 14 squares. How? Let me draw this. 1, 2, 3, 4, 5, 6, 7. Okay, you know it is 7, 8, and 9. So here we have 9, right? 3 multiplied by 3, we have 9. Now 1. 1 is the whole square, that is 1. Now where is this 4 coming from? 4 is coming from this 1, right? Then 2, then 3, and then 4. Okay. So here there are also 4 squares. 1, 2, 3, and 4. We have 4 squares here as well. So this is where the 4 is coming from. So when n is equal to 3, we have 14 squares. Now let me show you the mathematical calculation here. If n is equal to 0, then the square is 0. Okay, we saw that. N is equal to 1, then the square is 1. N is equal to 2, then the square is 5. When n is equal to 3, then the square is 14. So we can see a trend from here. 1 plus, this is going to be 14. Now we can see a trend. The trend is the number of square is the previous number of addition of the previous squares. So the hint here is that the each value of n, the number of square is the n squared plus the number of square from the previous values of n. So for 1 it was 1, for 2 it was 2 previous 2, I mean the square of 2, and the 3, it is the square of 3. So together it has 14. And if we go to our question, we can see that when the number of square is 4, the answer should be 30, right? Now, if we follow this trend, if we follow the trend, n is equal to 4. So if I add them all the squares, previous squares, then we should get 30. So 1, 4, 9, 16. So we get 30. Now when n is equal to 5, it should give us 55, right? Now here our solution, our trend says that if I add up all the numbers, all the square numbers from till 5, then we should get 55. So you can see here, 1 plus 4 plus 9 plus 16 plus 25 is equal to 55. So this is the solution. Now we just have to code it up. To code that, let me write const then number square function. We are going to take one parameter n, and then our function. So we need to use a loop here. Why? Because whatever the number is, we need to add all the numbers before that. So for I is equal to less than, okay, this one, less than or equal to, it has to be less than or equal to, and let squares is equal to 0. And now square is going to be addition. Oh, before going there, let me show you what math.power means. So if you go to the endium docs, you can see that the math.power static method returns the value of base raised to the power, that is math.power x2. So that means that math.power, here the first one is going to be the base and the second one is going to be the exponent. So we saw from this one that our base is 2, exponent is square. So this is going to be the same, but this is going to change with every iteration, right? This is changing, but this, our exponent square, is the same. So we need to use this method. Now if we go here, math.power, what is changing? This is the base. Our base is changing. Remember, it is, if I, the input number n is equal to 5, then the base is going to be 1, 2, 3, 4, and then 5, right? So I is changing and our exponent is going to be the same. It is going to be the 2. So what is happening? It is 0. Then if I give n is equal to 5, then it is going to play loop 5 times and add all of them. Return console.log is equal to square. Now if I call this and input 5, it should give me the answer 55. Let's see. See, it is giving me 55. Now if I give 4, it should give me 30. If I give 4, it should give me 30. If I give 1, it should give me 1. If I give 2, it should give me 9 maybe. 9. 5. Okay, our 2 was 5, right? 2 was 5. If I give it 3, it should give me 14. So this is the solution of our problem. See you in the next video.